Hello, everyone. Welcome back. Today, we're going to be talking about systems of equations and solving them. So, there's two methods for solving systems of equations that I'm going to talk about today, and they are substitution and elimination. So for A, I'm going to use substitution. B, I'm going to use elimination. And once we've done a few examples, I'll also talk a bit about when we want to use elimination versus substitution. I will say both will work for any problem that we do. It's just that there's times when substitution's a lot easier given the equations we have, and there's times when elimination's a lot easier given the equations we have. And so it all just depends. Okay. Later on in the next lesson, we're going to talk about word problems with systems of equations. So that's not today, that is next day. But there will be word problems involving systems of equations as well. So what do I mean by a system of equations? I mean, where do two relations meet, right? And so there's three options for systems of equations. If the slopes are the same and they're parallel, then there are no solutions. If these slopes are the same and the y-intercepts are the same, meaning it's really the same equation twice, then there's infinite solutions because it's really just drawing the same line twice. Or the third and most common option when we have two lines is that they meet or they intersect at exactly one point. And that's the case we're going to be looking at today in full is the cases where we have two lines that are not parallel and that are also not the exact same line, and so they're going to intersect at exactly one point. And in fact, all lines that don't have the same slope will intersect at exactly one point. However, all lines that do have the same slope, either they have infinite solutions or no solutions, because either they have the same y-intercept as well, meaning it's the same equation, so they have infinite solutions, or they don't have the same y-intercept, which means that they're just parallel lines that never ever meet ever, no matter how far along we go. And so that's what we're going to look at today. When you're asked to solve a system of equations, what they're really asking you is where do these lines intersect? Where is the point where these two lines intersect? So we're looking for not another line here to solve the system. We're looking for a specific point, so a specific x value and a specific y value. Do remember to find both and then write that in a quick conclusion at the end, because often what people will do is they'll find one variable and then they'll forget to also find the other one. And the good news is, once you found one, it's very easy to then find the other. It's all about the finding the first one takes a lot more time and effort than finding that second one. So let's do it. Let's solve this system and find out where do these two lines, 2x plus y equals 3 and y equals 6s plus 11, intersect. So let's use what I'm going to call here substitution to do it. So I'm going to call this equation equation 1 and this equation 2. And I'm going to sub equation 2 into equation 1. Now, what do I mean by that exactly? I mean that over here we know that y is equal to 6x plus 11. And I also know that 2x plus y is equal to 3. So if y is 6x plus 11, then instead of 2x plus y, I could just say 2x plus 6x plus 11 equals 3. So you see what I did here? All I did is this used to be y, right, in this equation, and I just substituted 6x plus 11 into it because I know that y is equal to 6x plus 11. So that's what substitution is all about. It's about saying, okay, well, we know y is this, and we know this other equation has a y in it, so let's just swap the y for whatever it's equal to. And now we have an equation we can actually solve, because if we, simplify this, we're going to get something that is actually solvable for us here, right? Because we only have an x, we only have one unknown as opposed to having two unknowns now. So let's do that. We have 8x plus 11 is equal to 3, which means 8x is equal to negative 8, which means x is equal to negative 1. So that's our x coordinate. Now we're going to sub the x equals minus 1 back into one of these equations, doesn't matter which. I'm going to do it into 2 because I feel it would be easier, so let's do that. Now I'm going to sub x is equal to minus 1 into equation 2. So y is equal to 6 times negative 1, right? Because we said we're subbing x is negative 1 into here, plus 11. So that's negative 6 plus 11, which is 5. So therefore, negative 1 comma 5 is the solution to the system. Or another way to write it that would also be equally correct would be negative 1 comma 5 is the point where the two lines intersect, right? Because essentially it's the same thing, whether we say it's a solution to the system or it's where the points intersect. Very good. All right, let's try B. And for B, I mentioned that I would not use the same method, that I would use a different method called elimination. So to do elimination, we need to subtract one equation from the other in order to completely eliminate a variable. Okay? So this one actually, I personally I prefer substitution. I think substitution makes a lot more sense in a lot of cases. However, I do want to show both, and both do work equally well. Just some people prefer one over the other. I find elimination people make more mistakes because when they subtract, especially, they'll often forget that they're subtracting, and some will be added, some things will be subtracted. So I feel it's easier to make a mistake this way, but I will show you how to not make a mistake with that here as well. Okay, so first things first, we need one of the variables to line up perfectly. So I'm going to actually change this equation. Let's call this equation 1, this equation 2, and let's make a new equation, equation 3, by multiplying equation 2 by the number 2. So 4x times 2 is 8x. Y times 2 is 2y, and 7 times 2 is 14. Now, why did I do this? Why did I feel it was necessary to make a third equation in order to use elimination? It's because I want to eliminate y entirely, and if we add these two equations together, y will be eliminated. So now I'm going to add equation 1 and equation 3, so that's 3x minus 2y equals to 8. And then over here we have 8x plus 2y equals to 14. I'm going to add these up and I'm going to make another equation with that. So let's add them up. What's 8 plus 3? That's 11. So 11x. Negative 2y plus 2y is just 0. So we're going to skip that part. 8 plus 14 is 22. So therefore we have 11x equals 22. So that just solves to x equals 22 over 11. So x is equal to 2. Okay, now I'm going to sub x equals 2 into, let's just say equation 2. It doesn't actually matter which equation you do. As long as it's one of the original equations, you should be good. 4 times 2 plus y is equal to 7. That means 8 plus y is equal to 7, which means y is equal to negative 1. So therefore, the solution to the system is 2 comma negative 1. Oh. Awesome. Very good. Okay. Let's try C. So for C, does it make more sense to use substitution or elimination? Now, again, you can use either one, and I personally would probably actually go for substitution here if I was doing it on my own, just because that's my preferred method. However, in terms of what most people would do here is what I will actually do here, which is elimination. Because you might notice that we have plus y and plus y on both. So what we can actually do is we can say this is equation 1, this is equation 2. We could do equation 1 minus equation 2, or vice versa. Equation 2 minus equation 1 will also work. So to do that, let's line up the two equations. And we're going to subtract one from the other. Now, this is a part where a lot of people make mistakes. People will forget that we're subtracting. And so some of the numbers will be added, some will be subtracted. So make sure we're always subtracting here. So 4 minus negative 2 is going to be 4 plus 2, which is 6x. Whereas a lot of people would add 4x and 2x, or negative 2x rather, and just say, oh, it's 2x, which is not correct. So make sure that we're, taking into account that extra subtraction sign there so that we're doing it properly. Plus y minus plus y would just be y minus y, which is 0, which is why we're subtracting in the first place, to get rid of that y. And then we have 8 minus negative 10, which is 8 plus 10, which is 18. So this is 18, not negative 2, which we would get if we added them. Now we get 6x equals 18, which means x is equal to 3. And we're going to now sub x equals 3 into equation 1. Now it doesn't matter which one you do, I just think equation 1's a little bit simpler. So let's see, we have 4 times 3. Plus y is equal to 8. So 12 plus y equals to 8. So y equals to negative 4. And therefore the solution to our system, or I'll just say the solution, is 3, negative 4. Good. Awesome. Okay. Then let's go for D. Okay, so D is x plus 2y equals to 6, and 3x minus 8y equals to 4. So for this one, I guess we did elimination twice already. Let's do substitution this time. But before we can do that, I need to rearrange one of these equations. I'm going to rearrange equation 1 and make it into a second equation. Actually, this will be our 1 and 2 like normal. We'll do this into a third equation, let's say. X is equal to 6 minus 2y. So what I've done is I took equation 1 and I rearranged it to make it so we have x equals to blah, blah, blah. Because that's how we're going to take that equation. We're going to sub equation 3 into equation 2, right? Now everywhere instead of x, we'll put 6 minus 2y. So we'll do 3 times x, right, from equation 2, which instead of x is 6 minus 2y because we're substituting that in, minus 8y is equal to 4. And now we need to solve for y. So let's use our distributive property to get 18 minus 6y, right? Just recall that we're going to multiply the 3 by the 6 and by the minus 2y, right? And then we have minus 8y equals to 4. So that's going to be minus 14y equals to minus 14, which means y is equal to 1. Now we must solve for x, so I'm going to sub y equals 1 into equation 3. And now again, you can sub it into any equation, but I chose equation 3 because that'll be simplest. It just gives us x equals 6 minus 2 times y, which is just going to give us 4. So therefore, our solution is 4, 1. And there we have it. There we have it. Very good. All right, well, that is it for substitution and elimination, just solving the systems. What we will do, though, on a future day is we are going to be doing the solving problems by solving systems of equations. This homework, I do suggest trying this on your own as well, but I will be taking this up starting in the next lesson. I think next lesson we'll do the first 5, then there will be a separate lesson for 7, 8. We'll see. Actually, maybe we'll do 4 and 4. Actually, we'll see if it needs to be broken down into 2 separate lectures or just one. But either way, I will be taking up each and every one of these questions in the future, just so I can, you can see more examples of substitution and elimination, especially after you've tried it for yourself as well with this. The other challenge with the word problems is this kind of combines the last 2 things we did combined, right? Because the session before this, we talked about taking words and making them into an equation. And so we're going to have to use that skill and our substitution and elimination skills in order to solve these next questions. So that's a topic for next day. So we'll focus on that for next day. Good work today, everyone, and I will see you next day. Bye, everyone.